Aryabhata, the ancient scientist who saw the world differently. Welcome, everyone, to another journey through time. Today, we're meeting a brilliant mind from ancient India, Aryabhata, the mathematician and astronomer who dared to see the world differently. Aryabhata or Aryabhata, for 550 CE, was the first of the major mathematician astronomers from the classical age of Indian mathematics and Indian astronomy. His works include the Rayabhaya, which mentions that in 3600 Kali Yuga, 499 CE, he was 23 years old, and the Arya Siddhanta. No exact date marks Aryabhata's birth, but historians believe it was around 476 AD in Kusumpur, historic city in ancient India. Even as a young boy, Aryabhata showed a curious mind and a thirst for knowledge. He studied many books on mathematics, astronomy, and ancient philosophies. He used to study books even far above his academic level. Unlike most children who learned from priests or at gurukuls, residential schools, Aryabhata likely traveled to renowned universities like Nalanda, a center of learning that attracted scholars from across the world. Here, he nurtured his skills in mathematics, astronomy, and even subjects like medicine. Both Hindu and Buddhist tradition, as well as Bhaskara I, CE 629, identify Kusumapura as Taliputra 8, modern Patna. A verse mentions that Aryabhata was the head of an institution, Kulapa, at Kusumapura, and, because the University of Nalanda was in Pataliputra at the time and had an astronomical observatory, it is speculated that Aryabhata might have been the head of the Nalanda University as well. Aryabhata is also reputed to have set up an observatory at the Sun Temple in Tarragana, Bihar. Aryabhata wasn't afraid to challenge existing beliefs. Back then, most people believed in the geocentric model, which placed the Earth at the center of the universe. But Aryabhata, through his careful observations and calculations, proposed a revolutionary idea: the Earth rotates on its axis and revolves around the Sun. This concept, known as the heliocentric model, was a radical shift from the prevailing belief system at that time. He didn't stop there. Aryabhata devised ingenious methods to calculate the positions of planets and eclipses. For example, he developed a system to track the apparent movement of the sun across the sky throughout the whole year. This helped him create a calendar that was more accurate than those used at the time. He even calculated the length of the year to be very close to the value we use today: 365 days, 6 hours, 12 minutes, and 30 seconds. His understanding of eclipses was groundbreaking. Aryabhata realized they weren't caused by divine intervention but by the interplay of light and shadow. He explained that a lunar eclipse occurs when the Earth casts a shadow on the moon, and a solar eclipse happens when the moon blocks the sun's light from reaching Earth. His knowledge extended beyond science. He even wrote about subjects like gravity and the concept of time. Aryabhata's work laid the foundation for future mathematicians and scientists, both in India and around the world. Aryabhata wasn't just an astronomer. He made significant contributions to the field of mathematics. He invented and simplified ways to solve complex equations, using algebra, though the term wasn't used then, to find unknowns in equations. He understood concepts like trigonometry, using calculations to determine relationships between angles and sides of triangles. His work with numbers was even more remarkable. Aryabhata is credited with making significant contributions to the invention of the concept of zero. While the idea of zero existed earlier, he formalized its use in the decimal system, a system where the position of a digit determines its value. This was a very important step in the development of modern mathematics. By using this method, long and complex calculations were made possible to solve in the fields of astronomy, geography, and civil construction. Some of his major contributions to the field of mathematics are as the place value system and zero approximation of value of pi trigonometry indeterminate equations algebra. Aryabhata's theories faced criticism in his time, but his ideas eventually gained acceptance. His work on planetary positions and eclipses proved remarkably accurate. Centuries later, scientists like Copernicus built upon Aryabhata's heliocentric model, further proving the correctness of our understanding of the solar system from Aryabhata's proposed model point of view. Today, Aryabhata is considered one of the greatest scientific minds of ancient India. His groundbreaking theories paved the way for future discoveries and continue to inspire mathematicians, astronomers, and anyone who dares to question and explore the world around them. The Arya Siddhanta, a lost work on astronomical computations, is known through the writings of Aryabhata's contemporary, Varahamihira, and later mathematicians and commentators, including Brahmagupta and Bhaskara I. This work appears to be based on the older Surya Siddhanta, which was a Sanskrit summary of Greek and Mesopotamian theories in astronomy and mathematics, and uses the midnight day reckoning, as opposed to sunrise in Aryabhatiya. It also contained a description of several astronomical instruments, the Gnomon, Shankhu Yantra, a shadow instrument, Chha Yantra, possibly angle measuring devices, semicircular and circular, Dhanurayantra, Chakra Yantra, a cylindrical stick Yasti Yantra, an umbrella-shaped device called the Chhatra Yantra, and water clocks of at least two types, bow-shaped and cylindrical. Direct details of Aryabhata's work are known only from the Aryabhatiya. It is also occasionally referred to as Aryabhata's Ashta, literally, Aryabhata's 108, because there are 108 verses in the text. It is written in the very terse style typical of sutra literature, in which each line is an atom memory for a complex system. The text consists of the 108 verses and 13 introductory verses, and is divided into 4 pdas or chapter. The Aryabhatiya presented a number of innovations in mathematics and astronomy in verse form, which were influential for many centuries. Aryabhatiya is also well known for his description of relativity of motion. He expressed this relativity thus: just as a man in a boat moving forward sees the stationary objects on the shore as moving backward, just so are the stationary stars seen by the people on Earth as moving exactly towards the west. Thank you for joining us on this journey through time. Aryabhata's story reminds us that curiosity, critical thinking, and a willingness to challenge the present status can lead to incredible discoveries. What will you explore and question today? Don't forget to leave a comment below and tell us what amazed you about Aryabhata. See you next time for another exciting adventure.